All right, so now we're going to finish up 5.3 and we're going to do some solving. So when we solve exponential functions, if a to the x is equal to a to the y, then we can say x equals y. Now we can only do that because both of these bases are a. If this was a to the x and this was b to the y, we couldn't say that. So as long as the bases are equal, we can say the exponents are equal. So for example, because both of these have 8s as the bases, we can say, okay, well, because the bases are the same, the exponents are the same, so x equals 9. Okay, now number 2, our bases are not the same. So I can't say that the exponent 16 to the 1, I can't say negative x equals 1 because the bases aren't the same. However, I could, if I wanted to, change 16 to be 4 squared. I'm not changing the meaning of this. I'm just replacing 16 with 4 to the second power. Well, now that the bases are the same, the exponents are the same, so negative x equals 2. Solve for x, divide by negative 1. X is negative 2. We've just solved that equation. So number 3, this should really have parentheses in it. I keep forgetting to add them. So we have 2 to the third to the x, and then 8 over 27. Well, because the bases aren't the same, we can't look at the exponents yet. So we have to change 8 over 27 to be 2 over 3. There we go. So do you guys agree that 2 to the third power equals 8 and 3 to the third power equals 27? So I could rewrite 8 over 27 as 2/3 to the third power, and then the exponents are equal because the bases are equal, so x equals 3. Okay, I'm going to leave 4 for you guys to try on your own and then check your answers on the answer key. Now number 5, same thing. I've got 2 to the x to the third equals 128 to the x. So I have to start by changing 128 to have a base of 2. So let's see, could I raise 2 to the something? 2 to the 5, that's 32. 2 to the 6th, not enough. 2 to the 7th, 128. So I could change 128 to be 2 to the 7th. However, technically we also have this x there. So we also have this x. And then on this side, we've got 2 to the x to the third power. Now, if you remember, when we have a power to a power, that means multiply. So this is just 7x. So now that our bases are the same, we can say x to the third equals 7 times x. So now I need to solve for x, and we're going to have to use a little bit more complex algebra skills here. If we have a power, we have to move everything to one side and factor. So our next step is to subtract the 7x over. So we get x cubed minus 7x equals 0. We could factor out an x. X squared minus 7 equals 0. Now if I set both of those equal to 0, I would get x equals 0. Okay, so there's one of my answers. And then I would also say x squared minus 7 equals 0, and I would solve. So add the 7 over, square root each side, x equals the square root of 7. However, be careful whenever you take the square root, it's technically plus or minus. So it's plus or minus root 7. So our three answers are 0, negative root 7, and positive root 7. Now in number 6, right, our bases aren't the same. So we have to say, okay, well, I want to change 32 to be 4 to the something. Okay, well, 4 to the second power, 16. 4 to the third power, 64. So I can't change 32 to be a 4. So I'm kind of running into a problem. However, couldn't I change the 4 to be a 2? Could I also make 32 into a 2? I could. So instead of making the 32 into a 4, we're going to make both of them into a base of 2. So 4 is going to become 2 to the second power. And then we still have the negative x plus 14. And then the 32 is going to become 2 to the 5th power, and we still have the x. Now that they are equal, we can say the exponents are equal. So 2 times negative x plus 14 equals 5x. Distribute your 2, combine your like terms, and solve. I'm going to leave that for you to finish. Why don't you pause, finish solving this problem, check your answer on the answer key. Okay, let's look at number 8. So number 8, hopefully we can change all of these numbers into bases of 7. So I know 49 I could change into a base of 7 to the 2nd power, but what would be 2,401? So 7 to the 3rd power, not quite. 7 to the 4th power, that worked. So 7 to the 4th power. So 49 to the x is going to change into 7 squared, but we still have the x, times 7 to the x squared, that one I didn't have to change. And then we have 7 to the 4th power, but I still have that 2. So now this is where we really have to remember our exponent rules. Remember when we have an exponent and we're multiplying, that means we add the exponents. So this can now become 7 to the 2x plus x squared equals 7 to the 8. Okay, remember when we multiply, we add the exponents. So we get this. So now that we have both of them being 7, we can say the exponents are equal. So 2x plus x squared equals 8. Now we just need to solve. Because I have an x squared, we're going to have to factor. So subtract the 8 to the other side. So x squared plus 2x minus 8, right, because I subtracted the 8 to both sides, equals 0. We're going to have to factor. So what multiplies to negative 8 and adds to 2? That would be positive 4 and negative 2. If I set this equal to 0, I get negative 4. If I set this equal to 0, I get 2. Those are my 2 answers. Oop, there we go. All right, so remember when we have fractions, okay, I need to change this 27 into a 3. So 3 to the 3rd power is going to give me 27. So 3 to the 3rd power, but I still have that 2x. Now, if I have 1 over 3, then that means there was a negative exponent, and because it's just a 3, I know that it's just to the negative 1, right? 3 to the negative 1 would be 1 over 3, and then we still have 2 plus x. Now that they're both a 3, we can look at the exponents. So 6x equals, distribute in, negative 2 minus x. Use your algebra to solve. Add the x over. Divide by 7. X equals negative 2/7. One last problem, and then I want you to go back and try 9 and 11, and check your answers. So on number 12, we have e to the x squared, e to the 9x, and then 1 over e to the 18. So we're really close to having all of the bases the same, but we don't want to have this e on the bottom. So we're going to fix it with a negative exponent like we did last time. So we're going to say this is e to the negative 18. Now if you remember, when we multiply, we add the exponents. So this turns into e to the x squared equals e to the 9x plus negative 18. Right? When we multiply, we add the exponents. Now, set the exponents equal. X squared equals 9x minus 18. Because it's an x squared, we're going to have to factor, subtract the 9x over, add the 18 over. See what multiplies to 18, adds to negative 9, factor, and solve. I'm going to let you finish that on your own. Check your answers.